Hello everyone. In today's episode we're going to talk about the basics of soldering. If you're new to electronics you may not know exactly what soldering is, so we'll define soldering here. Soldering is the process in which a component is joined together with a circuit board, a wire, or another component. It's done by melting a filler material known as solder to make a solid connection. So solder's melting point is much lower than the melting point of the metal used for the component leads or the pads of the circuit board. So this allows the solder to melt while still leaving the component lead and the pad on the circuit board intact. So when we're soldering, essentially what we're doing is we're making these solder joints here, and that is the blob of the solder that connects the component lead to the pad of the circuit board and makes a nice solid connection. So the solder itself is one of the most important components of soldering, of course. In electronics there are two common types of solder: leaded solder, which is primarily used by hobbyists, and lead-free solder, which is primarily used in the consumer electronics industry. Lead-free solder is also used whenever a component will come in contact with humans or food. So items such as wearables, cakes, gingerbread houses, all those kind of things you want to use lead-free solder for. Now the different types of solder have different advantages and disadvantages. Leaded solder requires much less heat due to its low melting point. It melts at between 183 degrees Celsius and 188 degrees Celsius, depending on the formula. The main disadvantage of leaded solder, of course, is that it contains lead. So the advantages to lead-free solder, of course, are that it doesn't contain any lead at all. Newer formulations of lead-free solder generally have a lower melting point than the previous generation did, so they're not quite as difficult to work with anymore as they used to be. The main disadvantage to the lead-free solder is that it's very hard to make a good joint. You require the addition of flux. You can't just generally use the solder by itself, and because of that additional flux you also have to clean the PCB after you solder it, and generally it also requires between 217 degrees Celsius and 227 degrees Celsius, depending on the formula, to reach its melting point. So that's much higher than leaded solder, which means that on heat sensitive components leaded solder is going to be much less harmful to them. In addition to that, there are two formulas for leaded solder. There is the SN63PB37 and there's the SN60PB40. So 6337 solder is actually the eulithic compound of the solder, which means that it has a much lower melting point and it has an actual melting point, not a melting range. So this means once you hit 183 degrees Celsius, it's going to melt. There are also different types of solder. There's no clean flux solder that has a no clean flux core, and there's RA flux solder, which is a rosin core. I generally don't notice a difference between the two. What I would recommend is to make sure you have two different gauges of solder. If you're going to be using surface mount, then the finest gauge of solder you can get will come in very handy. For regular through-hole components, then a higher gauge like 22, 21 is perfectly fine. Also, it's good to choose a higher quality solder rather than a super cheap one. Generally, the super cheap solder will have a harder time flowing. It will also tend to sputter and spit at you. So just for ease of use, I like the MG Chemical stuff. There's also a bunch of other brands that are really good out there. So the next most important component to soldering is going to be the soldering iron. There are a couple different types of soldering iron available. So there are soldering irons like this guy here, and this is a fixed temperature variety. So there is no adjustable temperature on this iron. It's always running at its maximum temperature. So these are perfectly adequate for smaller infrequent soldering projects, but the inability to control their temperature is the biggest downfall. The lower quality ones will have a lack of a thermal cutoff, so those ones are going to end up burning out their tips really quickly. Even on a nice, decent quality Weller one like this, it generally stays very hot the entire time it's plugged in, so the tip on it definitely wears out much faster. So the other type is going to be something along the lines of a soldering station or a temperature controlled soldering iron. So you'll generally have a knob of some sort that you can adjust the temperature of the soldering iron with. So the big advantage is this lets you change the temperature based on the components you're working with. So if the component you're working with is very heat sensitive, you're able to dial in the temperature of the iron a bit so that you're not applying quite as much heat to the component. And generally you want to run the iron at a medium point. So it's a point where the solder melts easily, but it doesn't spit and doesn't smoke very much. So next up you have the soldering iron tip itself. And there are a variety of tips available. The two most common here are going to be conical tips and wedge tips. So a conical tip is also sometimes called a pencil tip or a shape B or shape I depending on the manufacturer. Shape I is generally the super fine tip version. This tip is often included with soldering irons and soldering stations, and it can be very effective, especially when you're soldering lots of through-hole components all at the same time. Since it can be actually used from basically any direction, the tip is completely round, so you can use any side of the tip. On these tips, the very end will not get as hot as about the middle point here. So you'll generally be using this section of the tip right here for the actual soldering work, and very rarely using just the direct tip. So the other common type is the wedge tip. And these are both wedge tips. The one on the right is a very fine wedge tip, and the one on the left is a standard wedge tip with a blob of solder on it because it's good to store your tips with solder on them. Keeps them from oxidizing. So for the wedge tip, there are two ways you can use it. You can use the line of the tip, or you can use the face of the tip. So for desoldering or soldering onto a ground plane or a large power plane, the face of the tip is very handy because it allows you to apply more heat, and it has better surface area contact than the tip of a conical tip or even the side of a conical tip. So generally on a wedge tip you don't want to use the rounded side. You only want to use the face or the line, and the line can be used to heat SMD components and solder them easily. And it can also be used to heat the actual leg of a through-hole component while you heat the pad with the face. Generally there's lots of debate online about whether a pencil tip is better or a wedge tip is better, but honestly in the end it really doesn't matter. The important thing is you use a soldering iron tip that you're comfortable with. So try out the different types, and once you find one that you're comfortable with, you'll probably stick with that one for the majority of your soldering, and there's really no reason to change if you enjoy a specific tip over the others.